Okay, in this video I want to work question 12 on page 267 of your book. This example shows you how to compute the mean and standard deviation of a general discrete probability distribution. So by the time you get to this problem, you should know what a discrete random variable is. So let me just describe the specific context of this problem. You'll find it in the narrative just preceding the number, this table in the problem. So these numbers in column C, so X is the number of new customers that a particular cable company is expecting to attract in the following year. Now, so there are some numbers that you see over here. There is some uncertainty as to how many customers new customers it might get the following year. So just as a rough estimate, they're saying maybe we will get 100,000 new customers, but with a probability of 10%. Or we might get 200,000 new customers with a probability of 20%. So this fx column that you see is the probability of that outcome. So we might get 300,000 new customers with a probability of 25% or 0.25, and the so on. So there's only a 5% chance that we might get 600,000 new customers. So why is this a discrete probability distribution? Because there are a discrete number of outcomes in the experiment: 1, 2, 3, 4, 5, 6. Now there's no reason why the cable company might not have gotten 450,000 customers, but again, just for marketing analysis, the company has bucketed the numbers into certain manageable groups, so that's why we have these discrete outcomes. So the question is, you can see that all the outcomes are not equally likely. So the question we are asking ourselves is, how many new customers might we expect next year? Okay, now you have already use the built-in function average in Excel when we did descriptive statistics in the first class. So let's dispense with one observation. Why can't I take these outcomes and simply do an average? So let's do an average. So the average is the expected value, so it's 350,000. So why can't we say that there are different likelihoods of these different outcomes? So I expect on average next year to get 350,000 customers. So I just use the average function. The reason I can't use average function is because implicit in that calculation is that all these outcomes are equally likely. When you add up a bunch of numbers, let's say you add up 20 numbers and you divide by 20 to get an average, you are saying that each number is equally likely to appear. Okay, but that is not the case in the problem that's been given to us. All the outcomes are not equally likely, so we cannot use the average function to say on average how many customers would we expect next year. So just as an extreme example, suppose all these outcomes had the probability of 10%. So the first, second, third, fourth, and fifth had 10%, then the last outcome would have a probability of 50%, and obviously you can see that the number of new customers I would expect would be biased more towards 600,000 than the others. Okay, so when we look at these this probability distribution, if you do a bar chart of this column D, you would get bars of different heights, and that is your discrete probability distribution. Now again, by this time in the chapter, there are two rules. Let me remind you of the two rules that any discrete probability distribution has to obey. One is that every probability should be greater than or equal to 0. Okay, so you cannot have any negative probabilities. So let me write this down. So any probability of any outcome rather has to be greater than or equal to 0. So you cannot have any negative probabilities, and if you go down column D, you will find that that is the case. The second property that any probability distribution, discrete probability distribution, has to obey is that if you add up all the probabilities over all the outcomes in the sample space, they must add up to 1. So let's just confirm that that's the case. I add up these probabilities and they do add up to 1. If they didn't, then we couldn't proceed any further. So we have done our checks. So the first question is, on average, how many new customers do we expect next year? So how do we compute the average value? So the first thing you do is, since all outcomes are not equally likely, you just take each outcome and weight it by its corresponding probability. So you take the outcome X and you weight it by its corresponding probability. Okay, so let me I like to center things, so here we are, and I will take the first outcome and I weight it by its probability, just multiply it by its probability. Let me center it. So I copy that formula down to the other outcome. So I do exactly the same thing for the other outcomes, and then I just add up the values that I just got, and I get 325,000. Notice that it's different from the value that we got, 350,000, if we simply did the average, use the built-in function average. Okay, so once we weight each outcome by its probability, and you can see just by looking at column D that the distribution seems to be a little more heavily weighted towards the lower numbers. Okay, and that's why the average has shifted from 350,000 to 325,000. So this is the average, and usually the term that's used to represent it is expected value of X, or the average. How much do you expect X to be? I expect it to be 325,000. So on average, I expect 325,000 new customers. Okay, so again, if I had to write this formula down for the average, so X bar is the average, is equal to sigma each outcome multiplied by its probability, and you add it up over all the outcomes. So that's the formula for computing the expected value for any discrete probability distribution. So now the question is, how do I compute the standard deviation of this distribution? So remember, the standard deviation, the informal definition of a standard deviation is how far on average individual values are from the mean. How far are they from the mean on average? So the average is your reference point. So the first thing, of course, we need to do is find out how far each item is from the mean. So X minus X bar. Okay, so here I go. Here's the first outcome. How far is it from the mean? The average X bar is 325,000, and I'm just going to make that absolute because I'm going to copy this formula down to the other cells. So here we have centered it. So I have computed how far each value is from the center. So for instance, this outcome 600,000 is 275,000 above the mean. Okay, so I've gotten the differences. Now remember, since I'm computing the spread or the dispersion or the standard deviation, some of the values will be below the mean, some of the values will be above the mean. So I can't have one cancel the other, and hence I'm going to square this number. Okay, so X minus X bar squared. Why do I square it? In order to get rid of the negative sign, so I don't have the negatives cancelling the positives. So let me see if I can make this a superscript. Okay, so X minus X bar squared. Okay, so here we go, equal to this value multiplied by itself. Okay, so it's a larger number. Let me widen the column a bit. I'll center it. and I do that for every value. So this is how far each value is from the middle squared. Okay, now we've already seen that the outcomes are not equally likely, so I need to weight each number by its corresponding probability. So I'll take this, let me just copy this formula, the text over here, so I don't have to type the superscript. Copy, paste. Okay, and I'll multiply this by the probability. So took each difference, the squared difference, and weighted by the probability. Why did I weight it by the probability? Because all the outcomes are not equally likely. So let's do that now. Here's the squared number, and I weight it by the corresponding probability. Okay, so let me center this once again, and I do the same for all the values, and I add them up. Okay, now since I squared the differences just to get rid of the sign, I have to take the square root of this number just to get the units back, to undo the damage that I did in the first place. So let me take the square root of this number, and there is your standard deviation. So let me get rid of the decimal points. And I'll center it. So the standard deviation is $130,000. So the mean, I expect 325,000 new customers next year with a standard deviation of 130 customers. So let me write the formula for the standard deviation. So this guy is the standard deviation, which we can represent by the letter S or the letter sigma. And remember, we have two letters to represent the mean also, so it doesn't matter which symbol I use. So S is equal to, what did we do? We took each value, how far is it from the middle, how far is it from the mean, I squared it and I weighted it by the corresponding probability. Okay, and then I summed it up over all the values and I took the square root. So this is the formula for the standard deviation of a general discrete distribution. This is how you go about numerically computing it, and the formula I wrote at the bottom is just sums it up, just shows mathematically the operation that I did. Okay, I hope this clears up how you numerically go about computing the mean and standard deviation of a general discrete distribution, and why you cannot use the built-in function average or the built-in function standard deviation. You cannot use those built-in function unless the outcomes are equally likely, which they're usually not. Okay, all right, so that's takes care of this problem.